All right, so let's take a look at, oh, I think we just did this problem, didn't we? Yeah, I just did this one. I'm ready for the next one. Yeah. Okay. Um, we want to we want to show that the cotangent of theta is equal to cosine of theta divided by sine of theta. That is one of the quotient identities. There's three of them. In class, we derived one of them, so here we're deriving another one. And over here, this is just reminding us of some definitions that we're very likely going to use. And the um, the triangle up here is just to help us, with all of the ratios, and also to recognize by the Pythagorean theorem that x squared plus y squared is equal to r squared. And since r is a distance, r is also positive. So when you're verifying a trig identity, when you're trying to prove this, we need to start either with the left-hand side or the right-hand side of the equation. We can't yet treat this as an equal sign. More or less, I'm treating this as a true or false statement. If it's false, I can provide a counterexample, and if it's true, I want to prove it. You may remember that phrase and stuff from geometry when you did the two-column proofs. So I'm going to start, well, I'll do it two ways. I'll start with the left-hand side at first, and then I'll do it again starting with the right-hand side. So our left-hand side of the equation, and I usually just abbreviate left-hand side with LHS. If I start with the cotangent of theta, what can I do next? Well, about the only thing I can do next is look and see what the definition of the cotangent of theta is. And up here they're reminding me, and plus with the triangle, I know that the cotangent is the length of the adjacent side divided by the length of the opposite side. So it's x over y. Okay. And now, if I look at x over y, let's say that I take this fraction and I multiply it by the number 1, but I'm a little bit clever in how I write 1, and actually it looks a little bit complicated, but I'm going to have my numerator and denominator be the same value, and I'm going to pick 1 over r divided by 1 over r. All right, so when I multiply fractions together, you multiply straight across the numerator and straight across the denominator. When I multiply these numerators together, I get x divided by r, because I can treat this x as x over 1, I can treat this y as y over 1, and now I have a complex fractions within fractions, but when you multiply, you just multiply the numerators together and you multiply the denominators together. So if I do that here with the x over 1 and 1 over r, I get x over r, and here, if I take y over 1 and multiply it by 1 over r, I get y over r. All right. Now, I'm going to have to shrink this up because I need some more room. All right. So now, what can I do? I've used a property of arithmetic. I multiplied by the number 1, but there had to be a reason that I was doing that, and there is, because now this numerator, if I look up back to my definitions of these 6 trig ratios, x divided by r is the definition of the cosine of this angle theta. So I can replace x over r with the cosine of theta. And in the denominator, I can replace y over r with sine of theta. And now I have it because this is the right-hand side. We have shown that the cotangent of theta, by using the definition and properties of arithmetic and substitution, that cotangent of theta is equivalent to cosine of theta over sine of theta. So that's a big check that yes, that identity is true. We've verified it. We've shown that it's true. Now let's suppose that somebody was wanting to check their work and they didn't start with cotangent. They started maybe with the more complicated side, the right-hand side. Honestly, that's probably what I would have done. I probably would have started with the cosine of theta divided by the sine of theta and tried to somehow manipulate what this is equivalent to using definitions and arithmetic properties to illustrate that it simplifies the cotangent of theta. So using the definition of cosine of theta, that's why we listed it up here for you, and that's why we put the triangle in there for you as well. Cosine of theta, the adjacent side divided by the hypotenuse, is x over r. The sine of theta is the opposite side, the side opposite to theta, divided by the length of the hypotenuse, which is y over r. So I have a complex fraction, a fraction within a fraction. Remember, this long fraction bar is just simply division, so I think that students might find it easier to simplify this if you think of it as x over r divided by y over r, because somehow that triggers in the back of your mind when you learned that division was the same thing as multiplication by the reciprocal of the divisor. If I change this division symbol to multiplication, I have to take the reciprocal of my divisor here, and I get r over y. So let's shrink this up to give me a little bit of room. When I multiply fractions together, all you have to do to multiply fractions together is multiply the numerators together and multiply the denominators together. And now, if I reduce this fraction to lowest terms, I see that the numerator and denominator have a common factor of r, and r divided by r is just 1, so this fraction reduces to x divided by y. And if I look back at my definitions, we define the ratio x divided by y to be the cotangent of this angle theta. And that's the left-hand side of the equation. And I started with the right-hand side, so we have verified that the cotangent of theta is equal to the cosine of theta divided by the sine of theta. And we did it both ways. We did it starting with the left, illustrating that you get it to the right, or starting with the right to the left. Really, when I did this, I just did this operation in the reverse order when I started with cotangent theta. Remember, with the equality, you can reverse the order, look at it from the left to the right or from the right to the left. Hope that helps, and I'll talk to you later.